So here's example 19 in the integration topic. We're doing inverse trig functions. I've already done 17 and 18. Check them out first if you haven't looked at them. We want to integrate these expressions either into inverse sine or inverse tan functions, and by identifying quite quickly which of the two it's going to be. So in example 19, find the integral of 1 over root 25 minus 9x squared dx. Clearly, it's looking like the form of inverse sine x. So we're going to tackle that. What we want to do, as we have been in the past few, is we need to try and arrange our denominator in the form of a constant squared term minus a unitary x squared term. So clearly we don't have that. We've got a 9x squared. So the task is always to take a common factor of whatever the multiplier of the x squared term is. In this case, it's 9. So I know that before I can do anything, still got my surd. I'm going to take a common factor of 9 out of that. It's not ideal because I'm going to be left with a constant term of 25 over 9, but that multiplies out to give me the 25, and I've got minus x squared dx. Okay, so that's me taking a common factor of 9. If I'm taking that 9 out of the square root sign, then I'll have to take the square root of 9, and I'm left with that coefficient there of 3 times the square root of 25 over 9 minus x squared. With respect to x, I've nearly got it in this form of a squared minus x squared. Basically need a difference of 2 squares. I can take the third, see that 1 over 3, that's basically a third out there. I've got 1 over the square root of 5/3 squared minus x squared with respect to x, and that is me with my integral in the correct form. I've got 1 over the square root of a squared minus x squared. So according to the standard form, a is going to be 5/3. 1 over a, of course, would then be 3 over 5. Now, it's inverse sine, so we're not going to have a 1 over a multiplier at the beginning. That's just the inverse tan. So we're just thinking of putting a as a fraction over under the x. Okay, so let's just check what we do next. We want to keep our third multiplier, don't forget that. So our solution becomes all of this stuff is the inverse sine of x over a, and a is 5/3. I'll just put it here in that form there, plus c. And we know that dividing by 5/3 is the same as multiplying by 3/5. So that becomes 3x over 5. Okay, 3/5 x or 3x over 5 plus c. There's my answer. Okay. Starting to get the hang of it. So just make sure that you've got the shape of the two and know the difference between inverse sine and inverse tan. There's our answer. There's another couple to check these out as